So Lloyd is our co-founder. He's our CTO. But he's a lot more than that. Lloyd's the father of Looker. Looker actually was Yucker with 2 L's for Lloyd originally, and then we thought that was weird and changed it. But it retains his spirit. You know, Lloyd has been around the industry for a long time. He was a databases and languages architect at Borland. He was an architect on Netscape Navigator. You know, and he was the CTO of one of the first crowdsourced businesses, Live Ops. And you know, I think to touch on something that Mark said, you know, this idea of ideas come from seeing pain in the world. I think that's exactly where Looker came from for Lloyd. That he saw the pain of not being able to understand what was going on in your business, not being able to understand, you know, to sort of democratize your data, spread it around your organization, let everybody ask questions and get answers. And at LiveOps, and then in successive jobs, he sort of started to see this power because he built tools, internal tools that let people do this, and he saw how powerful it was. And he said, we have to generalize this. We have to make it possible for everybody to do it. And that's where Looker came from. So without further ado, I give you Lloyd Tabb.
Yesterday, Frank talked about the 3 big bets that Looker made, and I want to actually first by thanking you for all the big bet that you've made on Looker. There's a lot of choices, and betting with your intellect and your energy and your brain power into our ideas or Looker's ideas is a really big bet, and I really do appreciate it. Today, I'm going to talk about the importance of language. Language is really special to me. I've been thinking about language for my whole career. And there's a philosopher named Noam Chomsky who, he's a cognitive scientist, a linguist, and a philosopher. And he has a theory called the theory of language, which essentially comes down to that if you don't have words for something, you can't think it, that thought is language and language is thought. And that when you put words to things, that's how ideas are transmitted between each other. That's how we actually operate internally, and the atoms of our ideas are really words and language. This affected me early. I got really excited about language, and I saw the same thing with, I believe the same thing is true in lots of areas, in computer languages, in human languages, and actually in the languages of business that we're all creating when we actually write in Looker. Well, we actually create the languages with which we all think about things, and I want to talk a little bit about that. So different languages in human languages have different strengths. I was at dinner with my son the other night, who's in the audience, and he was telling me that in German, the word Vergnügen, which was an old VW ad, I don't know if you remember the Vergnügen VW ad, it actually literally means the joy you get when driving a car. Right, like literally, and it's a German word, it's like, which is great. And then, I was talking to somebody else who works at Looker, and he said, man, Looker is so dope. Right? And that's a new word, too, for me. I mean, it was like, oh, dope, wow. That means another thing. But I learned the context of the word dope. And all, right? And new words are getting added to our language all the time, and a lot of times if you look at like what gets added to the Oxford English Dictionary every year, it's a lot of words around technology, but it's also a lot of words around culture and around words about how we interact, and so language is growing and it gets bigger all the time, and the ideas and the things that are happening in language are things that happen in our culture, in our part of our world. Different languages are really good at describing different things. So French is the language of love, and German is the language of precision, and there's an old saying that Eskimos have 21 words for snow, which was debunked on the internet and then rebunked on the internet. Somebody actually said, no, that's not true, but it actually is true. They do have 50 words, actually. And the 50 words for snow actually allow you to describe the very nuances of the different kinds of snow. Is it frozen snow? Is it light snow? And if in the environment, those words are important because the nuances are important. In my house, I grew up in a house where there was some Yiddish spoken, and I can just tell you that there are 100 words for loser in Yiddish. There's a very big difference between a nudnik and a nebish, and there's lots of them. So precisely describing how I was broken or how other people are broken is very important in Yiddish, but because, I don't know, but anyway, so computer languages are also really interesting. If you study all the innovations in computer science, you can actually find all of it in language. So it's really interesting to find, like, as you see, so I'll just start at the beginning, and then in the beginning we had processors that spoke machine code, and we invented an assembly language which was very specific to each processor, and that assembly language allowed us to program so we didn't have to type in ones and zeros into the computer and toggle switches. And then we started building, we realized that we wanted the same program to run on different machines, and so we started developing higher level languages, and the first languages were like COBOL and Fortran. COBOL was a common business-oriented language, and then Fortran was a formula translation language. And then some smart guys at Bell Labs came up with a common assembly language, which was basically C, the C language. And that has actually, they got it right enough that it actually runs on almost every processor ever built. The first thing that you do is you build a C compiler so that you can get access to all the ideas that run on other machines onto your processor. So that's the first thing. So it's a common language of machines. And then from C, that low level, the low level C, there are a lot of new ideas that came into computer science, and so like object orientation happened, so then there was C++ and Objective-C, and then we got ideas about distributed processing, so Go shows up, and Java, we get ideas about garbage collection that we don't want to do the memory management anymore, so we had Java, and so different languages in different, in normal computer sciences actually are about expressing new ideas in the way we actually interact with or build stuff in machines. Also early in computers, we had, people didn't know how to operate computers. First computers were all command line based, and only people who were really good with computer languages could actually use them. But then we wanted to get people's computers into people's homes, and people didn't know how to program or didn't know the language, couldn't speak language. So we built gesture-based interfaces so that we could all interact with computers. And so the mouse and the windows, and we had common, and so it's like a toddler learning without language to be able to interact with a computer. And then we started building stuff on top of this so that we had applications that would do things. And we built gesture-based interfaces on top of very complicated things. And we started building these tools that were at the simple level work, but we started stacking gestures on top of each other. So if you look at old, I don't know who's ever used like business objects or the earlier generation data tools, they were all visual programming based. And what you had to do is draw things and then stick pieces of code under things. And so but it worked because people didn't have language. We're now seeing a return to language in computers. So I don't know if you saw our Slack announcement, but everybody got really excited because you could actually type command lines at Looker, right? So that it would return you data. When you make a query in Google, you're actually issuing a command against the global memory to conjure up some results, right? And you're giving Google a command based on what you know, and it returns you results back from that. If you use navigation in your car, or if you use Alexa or Siri, there's a syntax with which you speak to these robots or these that are actually commands. And so there's a return to language to interface to computer because language is much more efficient than gesturing, and it's stackable. You can actually do one thing and then the next thing. I can give you instructions in an order that I can't give you. The gestures don't necessarily have any order or time. So languages becomes really important. Let's roll to data, which is why we're all here. At the same time that C was happening, a language called SQL was happening, and I'm sure almost everybody here knows SQL. SQL, so it evolved at around the same time, and it was a common way of asking questions of databases, the same way C was a common way of actually talking to microprocessors. Alan Turing talks about a Turing complete processor, which means that you can basically you can write a C compiler for it, right? And data, I actually think of SQL as being Turing complete for data, which means that any data transformation can be expressed in SQL. And there have been a lot of times where people have gone away from SQL with MapReduce and other things, but the ability to do the transformations were incomplete. So they would build a lot of things, but there would be pieces that were missing, and you couldn't solve all the problems. So SQL is pretty amazing. It is Turing complete. It is, first of all, it's everywhere. Almost every database that's taken seriously supports SQL or some dialect of SQL. It's functional. You can you write a query and it works. And everybody's kind of recognizing that SQL is the core thing, so they're all implementing SQLs on top of all of their databases, even if they didn't do it before. So we're seeing all of the Hadoops of the world producing SQL, but SQL has some problems. First of all, it's write-only, so it talks really well, but it doesn't listen very well. I don't know if you've had this experience, but you write a SQL query and you come back a month later and you go, what was that? What was I doing? It's very hard to parse a big SQL block and understand exactly what the SQL query does. The other thing that it's bad at is reusability. So it operates more like a lease, where you take a copy of the lease and you make some changes to it, and then you put it in a file, and you take another one, and you make a copy of the lease. And so you've got to figure out which copy of the lease should I use, because now you've got some good ideas in the lease, but that old ones doesn't have it, the new one does have it. Which one should I make a copy of? And so there's these propagation errors that happen. And it's really easy to do badly. You can write queries that will take down your database, right? Everybody's nodding their head, right? So you write a bad query. You forgot to put a join predicate, and there it is, boom, right? Your whole SQL, your server comes down. And worse is that it's not inventing new language for you. So the atom of SQL is to pull a data set back. It doesn't help you define the language that's the most important, which is the language that you're building for your business. Is it revenue or, so enter LookML. First, we wanted to make it a way so that you could write reusable queries easily and have a syntax. So the beautiful thing about Looker and LookML is that every single query is expressible in 4 terms. Right? It's the base view that you're going at, which is the model and basically the relation construct that you're dealing with. And then it's a set of fields, whether they're dimensions or measures. And these are your business terms. These are the way that you think about data. These are the words. What words do you want? Then there's a set of filters, which are which data do I want, which data don't I want, and a sort. And that will return you a result set from a query. And the beautiful thing about it is that every single piece of the result also has a link to dig in further in the same syntax. Right, so this is this recursive thing, which is that you go out and you issue a query, and whether this is from the command line, whether this is from the Explorer view, whether this is in a dashboard, or whether this is in the API, the interface is exactly the same. You just issue a set of words that you're interested in, and the results come back, and they drill, and they dig in. And what this does for you is it allows you to build a language with which you can describe the thing, your words for snow. And when I was at LiveOps, we had a bunch of measures around call center data. And so we had a measure called a CHUP, which was that the caller hung up before they spoke to an agent, right? And that's a very specific word, and it was expressed in a very specific way. It was a call that was less than 20 seconds that didn't have an agent attached to it. That was a CHUP, right? Or Daniel, when he worked at Upworthy, he had for an article, it had the number of attention minutes, which was the number of minutes with which the browser was open to a web page where somebody was looking at it and the window was on top, right? And that part of how much of the article did they read he was trying to do. And so those are the business terms that you define. And in Looker, you define those things in exactly one place. You define them once. So we wanted the design constraints of LookML were you should be able to build your business terms. You should define it exactly one time. And you should define the relations exactly one time. And from there, you should be able to ask any question. And that was the goal of LookML, to build to get all of the power of SQL, but to have the reusability at the word level, at the idea level. And I think that's what we've done. And so today, it has, if you've been a long-time Looker customer, you know that early LookML doesn't look anything like LookML does today, right? It has the same concepts, but the words have changed because we're trying to make it easier. We're trying to reduce complexity. We're trying to reduce friction into what it takes to build this stuff. And good languages are live languages. And so we have some great stuff for you today around LookML. Everything that you know is still there, and we think that you're going to love these changes. So I'm really excited to have you see it. have great time building remember that what you're building is language for your worlds. And so it's important, the words that you describe change the way that your organizations think. And so you have it's a really great place to be. But anyway, thank you.